Hello, this video is going to help you review or learn parent functions. This video was intended for Math 3, College Algebra, Pre-Calculus, and Algebra 2. Okay, let's get started. This is the constant function. So what I mean by that is the number that is constant will never change. So if I put in values for x, what this means is the number here that's constant will never change. So in this example, I'm just going to change this to a number so you can see in fact it's constant. So I'm just going to pick 4 just for kicks. So that means if I substitute in -2 into the function, I'm always going to get 4. And I can do that for all the values. So constant function. It never changes on the y values. So now I'm going to come over to the graph and graph what I just created a table for. So -2, 4, and you're going to see this is -1, and the y value is 4, and I'm just going to finish out the points. And at this point, I hope you can see that when I draw a line here, and you want to make sure there are arrows on your line, you get a horizontal line with the equation y equals 4. This has 0 slope. And since y is another way of writing the function at x is 4, this function represents this horizontal line. Now let's do some characteristics of this function. So what is the x-intercept? Well, if you look at the graph, there aren't any x-intercepts, so that's none, or non-applicable. The y-intercept is right here at 0, 4. Remember, a y-intercept is a point. It's a point. So do not just write the number 4. Now we're looking at domain. So domain is a lot easier if you look at the graph. So what that means is, what are all the x values? What are all the x values that work or defined for the function? So this is what I like to show you. Remember, domain are the x values. So if I took a perpendicular line and I met up with all of the x values on the graph, which is the yellow, you're going to see that every x value on this graph works. So what I like to think about it is it's almost as if you're picking up the whole line and smashing it against the x-axis. So you can see it is all the x's on the line. So what we're going to call this, since we have an arrow on the end, is -infinity up to +infinity. I'm going to write the domain in interval notation. When we're writing -infinity or infinity, we always use an open parentheses, so this is open, because infinity is not a number. It's an action telling us to keep going across that number line. The range are the y values. And if you look at this graph, the y values are across, up and down, so it's vertical. Well, I'm going to use that same method where I take a line across the y-axis. So these are little lines, and there's nothing there until I get to, right here. There's a point at y equals 4. And that makes sense because the graph is constant. And then after that, I have nothing. I don't have any more y values that are defined for the graph. So this range ends up being one number, and that one number is the set of y equals 4. So that is the range. Now we're going to talk about increasing and decreasing. So increasing, of course, means you are going up or increasing, right? And then decreases is you are going down or becoming smaller. So this function here is neither increasing or decreasing because it is constant. So again, this will not be a conversation for this particular function. This also does not have an absolute maximum or minimum because the function, again, is constant. We'll be looking at those later at different graphs. This function is even, and that is because you could fold this function in half and it would be symmetric over the line y equals x. And I actually meant to say y equals 0. And then we don't have any other characteristics we have to worry about. And now we're at the identity function or the linear function. So it's called the identity function because if you find the values of y after substituting an x, these x's are exactly the same. So they are the same. So if this is -2, then the output of the function is also -2. Likewise for all the other values, which is why it's called the identity function. But it is also linear. You are used to this. And then I'll come over here and graph my function. And this function is one that you're very, very familiar with. And I'm going to draw my line in with arrows. And I'm going to go all the way across the graph, and I would like you to do that also when you are producing these. And now I can start looking at the characteristics. So what is the y-intercept? The y-intercept is found at 0, 0. Remember, intercepts are points on the graph. Intercepts are points that cross an axis, depending on if it is the x-axis or the y-axis. So it turns out here, the y-intercept is also the same as the x-intercept. Now let's look at domain. So I'm going to take that same method where I go from the graph up to the x-axis. And as I color, I hope you can see that all the values are going to be included. And I can likewise go the other way. So again, we have -infinity up to infinity. We're writing an interval notation. Now we're going to look at the range. And the range isn't that much harder. It just, it's a little different. So I'm going to go across horizontally up to the graph that meets the axes for the y's. Oh, I meant to go on the other side, so I better do that. Because here is the axes. And if you're not sure, just make yourself a quick sketch. There's nothing wrong with taking those extra couple minutes. Okay, so what we have here is an arrow. So this is -infinity, and we're going up to +infinity. So that range is the same as the domain, but for a different reason, because we are looking at the y values. Now we're going to look at increasing and decreasing. Well, if you remember, this function has a constant slope, meaning the rise over run is always the same, which is how you get that beautiful line. And if you were going to create those slope triangles, you would see you're going up the stairs. So this function is increasing from every x value on the line. It's going up or increasing. Now this function I just said is increasing, which means, because we think of it going up, there is no decreasing interval on this function. There is no absolute minimum or maximum in this function, no lowest or highest point. This function is called odd. It's odd because you can take the function and do two folds of symmetry. So here's the original, and if I was to take it and transform that, now I flipped it over this axis here, and then I could flip it one more time down here by folding a third. So I flipped here, and then I flipped here. This is considered odd. So this is an odd function. Absolute value function. So we're talking about distance away from 0 or distance away from a particular number. In this case, it is going to be 0. And if you remember, the output is always positive because we're talking about distance. So the absolute value of -2 is +2. And then likewise for all the other examples. So all the other examples will be the same. And 1 is positive, but again, we're talking about distance, so the output will be positive. Now we're going to graph these. So how does this one look different than the last graph that we looked at? Well, it's these little bars that tell us to take the positive value for the output. So at -2, I'm now above the x-axis. So all the values are going to be positive for the y values. So that's how you get that nice V. And I'm going to go all the way across the graph. And you're going to put your arrows. You got to put those arrows. That's that behavior where we go to infinity. So make sure you put those on the graph. Okay, the x and y intercept are the same for this graph. Then we get to the domain. So we're talking about all the x values. So here's an arrow, and here's an arrow, so I'm going to put some arrows on the end, and then I can see the domain is going to include every value across the the x-axis. So it's -infinity. Remember, this is interval notation. Now the domain and range has been similar for the functions we've been doing. That makes sense. However, the range on this one is going to be different. So the very first example we did was the constant function, and you saw that was different. So I just want to keep in mind that you know that the domain isn't always the same for all functions, and we'll see that later. So here's the original function. I'm going to look at the y values this time, and there's nothing here. No, right? There's no graph here. There starts being graph at the value y equals 0. Because remember, we're talking about range. And so now I'm starting to look at values of y on the graph. And you can actually see there's more than one y value for each x. You can see that. So this is going up to infinity. So it starts at y equals 0, and we're going to include the 0, y, because the value is defined at 0. So we include that value, and it's going all the way to positive infinity. So now we're back to increasing and decreasing. This function does have an interval where it's increasing and where it's decreasing. So there is an interval. So we're going to start with increasing first. So in the last example, we talked about the slope going up, and so it was increasing. So this graph is increasing starting at 0 for the x values, and then it's increasing across infinity because of this arrow. So this part of the number line has y values that are increasing. Now it's very important to look at 0. Now 0 is not increasing or decreasing. It doesn't increase and it doesn't decrease. It just is. 0 is one of those endpoints, but we do not include. We do not include 0. So we're going to create an open parentheses where we do not include 0, and we're going up to infinity across the x's to show that the y values are increasing. Now, likewise, we're going to do the other side. So the other side is going to be decreasing, and that's the slope idea again. Where if you were to draw those slope triangles again, these slopes would all be negative going down, which creates the function decreasing. So it's decreasing on that interval. So remember, 0 is neither increasing or decreasing. So the way we're going to write this one is we're going down, and this is infinity, or negative infinity, actually. So we start from the smallest and work up to the biggest value. So it's not included. So that's increasing and decreasing. This graph does have an absolute minimum, meaning smallest. And what kind of value? It's the smallest y value. That smallest y value is y equals 0. It has an absolute minimum, smallest value. It does not have an absolute maximum because the function is increasing to infinity in both directions, so there isn't one. Now we're going to look at symmetry. So symmetry, just to give you an idea, again, is an even function on this one because you can fold across the y-axis and you will get exactly the same thing on the other side. So if I was to fold this in half, we would get the image laying right on top of each other, so this is considered even. Ooh, x squared. You know x squared really well. So this is that quadratic function. I'd like you to write out the values being substituted, and that is because we often mistake the negative sign because sometimes we do not put it in our calculator correctly. So what I mean by that is when you substitute f of negative 2, sometimes we'll write it like this, and this is incorrect. If you put it in your calculator, you must put the parentheses because that means you have 2 negative 2's. So just keep that in mind, which is why I'm going to write it out because I don't want you to get mixed up. So I'll just go through and do the computation quickly. It's based on this function up here. It says multiply the same number. So that is what I'm going to do. And you can see all the y values or outputs are all positive, so we know we're going to be above the x-axis. And that is how you get the shape. So now we're going to start graphing. That's how you get that nice U shape that you're used to getting. And we are going to make sure that we put our arrows on the graph and start answering the questions. So what is the y and x-intercept? So there's only one value where it's crossing the x and y axes. Alrighty, and here we have domain again. So here's domain, we're looking at the x's. I'm going to start drawing little lines here, filling them in. Oh, there's an arrow, so I have to put a negative infinity value here because I could just keep going like I'm doing. Positive infinity on the other side. And so again, we're going from negative infinity to infinity. And then we're going to look at the range, which of course are the y values. So nothing. Okay, I start having something right here at y equals 0, and I'm going to include it. And then you can see right here, there are y values. I'm crossing the graph, and it's going to positive infinity. So include 0, it is defined if you look at your table. And then you're going up to positive infinity. Okay, next. Increasing and decreasing is very, very similar to the absolute value. So I'll go pretty quickly on this. So on this part of the graph, we are decreasing. I know there's an arrow up, but we always look from the negative x's. So the function is decreasing until you get to 0. So this interval are the x's, they represent the x's, and that's how we describe increasing and decreasing. So I did decreasing first, so I'll go ahead and write that first. So the function is decreasing from negative infinity up to 0, but we do not include 0 because 0 is neither increasing or decreasing. And then the remainder of the function is increasing, not including 0. We have increasing and decreasing. This function has an absolute minimum at the value y equals 0. It does not have a maximum value because of the arrows. And I'll go back and put that in black for you because I think it's easier for you to read. Okay, let's talk about symmetry. If you're symmetric over the y-axis, you can make that nice fold. And so this would be an even function. All right, x cubed, or the cubic function. This time you have 3 x's being multiplied. Okay, and then we're going to graph that function. Okay, remember to put the arrows on the graph. Okay, xy-intercept, same thing. 0, 0. And then we're going to look at that domain. So we're looking across on the x-axis. You're going to draw your values. Oh, there's an arrow, so I'm going to negative infinity. All of my values here that meet up, all my x values that meet up with the graph. Oh, there's an arrow. Got to write an arrow here. Looks like the domain is all real numbers or negative infinity to infinity. And you know the next thing is the range. So we're looking across the y values. We're looking across the y values. I'm going to draw a highlight. Oh, there's an arrow. So this is negative infinity. And you can see I have graph going all the way up. So I'm going up to positive infinity, which means my range is negative infinity on the y's, of course, all the way up to positive infinity. And then we're talking about increasing and decreasing. So this is similar to the linear function because the entire graph is increasing all the way up and across the x-axis. Because remember, when we're talking about increasing interval, we're actually talking about the x values. So I just want to make that really clear. We're talking about the x values. Even with decreasing, we're talking about the x values. Okay, range, we're talking about y, domain, we're talking about x. I want to make sure that that's very clear to you. Always x is for increasing, decreasing. So if I'm starting from negative infinity, you can see the graph is increasing everywhere, even though it's curved. So the rate of change is different. However, the function is still increasing everywhere. So all the x's create y values that are increasing. So there is no decreasing. There is no decreasing interval, so we don't have to worry about it. Now, since this function's increasing, there is no absolute minimum and there's no absolute maximum. You're not going to get a highest or lowest point. All right, is this going to be even or odd? Well, let's see. If I take this part of the graph and I flip it over here, and then I fold it down, I will get the two sections to lay right on top of each other. So this is odd.